An alternative method for calculating of the convolution is explained as follows. Let x and b equal to x minus 1, x naught, x1, x2. Later you'll practice on another variation of such an input, and h of b equal to h minus 2, h minus 1, h0, h naught, h1. B, the input and system's impulse response, respectively. Okay? Now, we write down a table, we provide a table. We want to find the output samples very easily just by looking at the information inside the table. The output denoted yn will be computed using the method in table 1.1. Okay. In the first row, we put input samples in order from the smaller one, minus 1, up to the bigger index. You see, it's sorted from small to big index. So, rightmost sample will be 2, then before it 1, 0, minus 1. Okay? What about the second row? We put the samples of impulse response. But how? The rightmost index is 1. Okay, so it will appear here below x1. h1. If we had h2, here it would appear. But it's not here right now. Okay? h2, h3, h4, x2, x3, x4. h1 is here. h0, h minus 1, h minus 2, h minus 3, h minus 4. Here, x minus 2, x minus 3, x minus 4, blah, blah. Okay? So, up to here, we have understood how to put the information in the first and second row of the table. Not the rest of the table. Okay. You see here, 2 plus 1 will be 3. So, y3 is the rightmost index for output. 2 plus 1 will be 3. Okay? Then y2, y1, y0, y minus 1, up to where? The smallest indices. You see, minus 1. Minus 2 will be minus 3. So, the output will appear from y of minus 3 up to 3. Then fill the other columns. So, up to here, first, second, and last row have been completed. What about the results? Okay. Think deeply. x2 is playing with h1. Then x1 is playing with h1. x0, x minus 1. There is nothing more. Okay? Again, rightmost input index x2, playing with rightmost impulse response h1, then sample before x1, playing with h1, x0, x minus 1, all playing with h1. The next row, x2, playing with h0, x1 with h0, x0 with h0, x minus 1 with h0. Okay? In another row, again x2 with h minus 1, x1 with h minus 1, x0 with h minus 1, x minus 1 with h minus 1. And the last info inside inner table, x2 h minus 2, x1 h minus 2, x naught h minus 2, x minus 1 h minus 2. In any cases, the sum of the indices 2 plus 1 will be 3. Okay? Here, 1 plus 1, 2. 2 plus 0, 2. So, in column-wise approach, the sum of the indices will be the same. 1 plus 1, 2. 2 plus 0, 2. There is no other alternation. Okay? 1 plus 1, 2. So y2 is sum of the information here. So y2 is equal to h1 plus h1 times x1 plus h0 times x2. y3 will only be h1 times x2. What about y1? You see here, the sum of the indices is 1, 1 plus 0, 0 plus 1, minus 1 plus 2 will be 1. And the same for the rest. So the puzzle is solved. Later from now on, you are an expert in responding to the result of convolution if you are going to have an examination related to DSP and convolution section. Okay? Very easily. Note the take home related to such an approach is having another indices here. For the first one, only add x3 and the same for the rest and find the result. Find the result based on tabular approach and the standard and classical formula we show. Okay? The next try to have x minus 2 and the same configuration. The third one having h2, the fourth one having h minus 3, and another ones having a combination of what we mentioned. If you solve such combinations, you will be an expert in convolutional approach. What about another method? Okay. Another similar method is based on the multiplication of two polynomials. High school mathematics. Very simple. Just present inputs as polynomials. X of p polynomials, p stands for polynomials. X of p is equal to x minus 1 for the previous example. X minus 1 times p minus 1 plus x naught times p to the power of 0, which will be 1 and we haven't written it, plus x1 times p to the power of 1 plus x2 times p to the power of 2. And there is nothing left more. Okay? What about h of p? h of p is equal to h minus 2 times p minus 2 up to h1 times p1. And the rest is very simple. Just multiply two polynomials. And I have no explanation for it. And inside the brackets will be y minus 3, y minus 2, y minus 1, y0, y1, y2, y3. And the result will be similar to the previous one, of course, definitely.